All right, today we are going to be looking at secants, and secants can create two different types of angles, an interior and an exterior. We're going to learn how to find the measure of those angles or the arcs that go with them. We can actually find either of them. Okay, so what I've drawn for you here is a secant. Okay, a secant is going to go through the circle and it is going to touch it at two different points. It's different from a chord because a secant does have to be a line. Okay, now the theorems we look at today work with chords and secants, but the secant does have to continue on, does have to be a line. So the first theorem you have is working with two secants, okay, or it does work with two chords as well, okay, and it's going to always be an interior angle. Okay, so for example, if I had another one here, again, could be secant or chord, the big thing is that it intersects inside the circle but not at the center. Okay, it's just going to be another random interior point, which is just why I call it an interior angle. Okay, anytime you want to find the measure of the angle, so let's call this one angle 1. We wanted to find the measure of it. What we want to do is we want to find the average of its arc and its vertical angles arc. Okay, so if we call this arc AB and we call this arc CD, the formula we would want to use for the measure of angle 1 is we would want to do 1/2, because that's going to help us find the average since there's two arcs, and it would be arc CD plus we'd want to do arc AB because that's its vertical angles arc. Because we know if this, whatever the measure of this one is, the measure has to be the same for the vertical angle. Okay, so again, you would add the two arcs, take half of it, which is the average, and that would give you the measurement. Okay, so that's what we're going to do here first for example 1 and 2, or excuse me, just example 1. So for example 1, okay, they give you A under example 1. Okay, they give you these two guys here. They tell you this one is 47 degrees. This one is 116 degrees, and they're asking you to find x. Again, interior angle, not at the center. Doesn't even give you the center of the circle, so don't ever make an assumption something's the center. Okay, so if I want to find x, it's going to be 1/2 its arc, which is the 116, plus its vertical angles arc, which is the 47. Okay, so if you would simplify that one, you'd end up getting 81.5 for your angle measurement. Okay, so again, just that idea of adding them and taking the average. Okay, for the next one, this one's going to be a little bit different for B. So same idea with having the circle. This time they're going to kind of intersect more like this. Okay, it tells you that x is right here, and it gives you 55 and 75 here. Now you'll notice these arcs don't match up with the x that we need to find. Now there's a couple different ways you could do this problem, but the easiest way I found is I'm actually just going to solve for y, because y does match up with those arcs. And then I know x and y are a linear pair, so they have to equal 180. Okay, so I'm going to go ahead and find y first by doing 1/2 of its arc, which is 75, and its vertical angles arc, which is 55. Okay, if you go ahead and simplify that one, you'll end up with 65 for the y. But again, these two are a linear pair, so if I subtract that from 180, I'll end up with 115 for my x. Again, not the only way to do that problem, but I seem to think it is the easiest way to do that problem. All right, so for C then, so C is actually going to ask us to find an arc. Okay, so again, they would kind of intersect like this. You've got 128. They actually give you the angle this time. You have 154, and you have x. So we're going to use the same formula, just have to put things in a little different place here as we work with it. Okay, so we would do our angle, which is 128, equals 1/2 arc plus arc. So it would be your 154 plus x. Now there's two ways you can go about solving this. I think it's easiest to multiply by 2 to get rid of the fraction, but some kids like to distribute. Doesn't matter to me which way you decide to solve it. That's completely up to you. Either way, you should end up with 102 as your answer for your x on that one. So same idea. If you're missing an arc, you're just going to have to solve for the x, work backwards a little bit, but again, working with the same idea. All right, so that's for our interior angles. Okay, now we're going to look at what happens if I have one that's on the circle, but it's not necessarily inscribed. We kind of treat it like an inscribed though. So if we have a secant and a tangent together, and the angle is on the circle, okay, so we're talking about if I would have a secant, okay, and then I would have a tangent. Okay, so something along the lines of this. And again, this one could keep on going because we've talked about the secant. It does need to keep going. Okay, so what we're going to do is I'm going to call this guy A. We'll call this guy B. Okay, this will be my angle. I'll just call it angle 2 right now. Okay, we are going to treat this like an inscribed angle. And if you remember, inscribed angles are always half their arcs. Well, you'll notice with the tangent, it kind of goes off into no man land. So that means the arc is going to start here, and then it's going to go all the way around till you get to here where the secant meets. Now, you'll notice that is a major arc, so I am going to throw an extra letter in there so we can name our major arc correctly. Okay, so if I want to find the measure of angle 2, I'm going to do 1/2 its arc. Okay, so its arc would be ACB. Okay, so just like an inscribed angle, we took half. We will always take half on this one as well. Okay, so if you look at example 2, you kind of have a couple problems where we get to practice this. So the first one on example 2. They tell you the angle is 116, and they're asking you to find, oh, and there is a typo on this one. It should be JLK, so make sure you do fix that. It should be JLK. I'm not sure if it's fixed on yours or not. It is incorrect on my copy of the notes. Okay, so if I'm trying to find that, that would be this arc right here, okay, that you are looking for. So if its angle is 116, that arc has to be twice as big. Okay, so our arc should be 232 for that one. Again, just working with that half or that times 2. Okay, for B, they actually give us the arc and ask us to find the angle. So just kind of doing the exact opposite for this one. Okay, so you've got your circle. This time they put it up here. And they tell you to find measure of angle RQS. If measure of QTS is 238, that would be this guy right here, and they're asking us to find that angle. Okay, well, if this is 238, okay, then I want to find out what is left over for my arc on top. So I can subtract that from 360, since circles equal 360. I believe that should give you 122 when you do that. And then 1/2 of 122 would give you 61 for your angle measurement. Okay, so again, just working with that half there. Okay, and the last type that we have is working with an exterior angle. Now this one can be done a couple different ways, and we'll look at that. It can be done with 2 secants, secant and tangent, or 2 tangents. And again, it will always be an exterior angle that you're working with. Okay, so what it's going to look like then again is kind of something like this. Okay, this would be an example of 2 secants, but we'll also look at some examples with tangents and stuff here in a little bit as well. Okay, so if we look at these ones, okay, you have A, we'll go B, C, and D, and we'll call this angle 3. Okay, so again, you'll notice that the angle is outside. That's why we call it an exterior angle. Okay, so what we're going to do for this one is if I want the measure of angle 3, it's going to be 1/2 the big intercepted arc minus the little intercepted arc. Okay, there will always be 2 of them. Okay, now we always have to make sure we take the big minus the little, otherwise you're going to end up with a negative, and that's not going to work so well for us. Okay, so it's the average of the big minus the little whenever we have an exterior. So a big part of this comes down to memorizing the formulas. Okay, so if we go ahead and look at the first one that we have here. Okay, they give you the circle. This time they do it with a tangent in a secant, which is fine. It's still on the outside, so it doesn't matter. They tell you this guy is 179, this arc is 71, and they're asking you to find your angle, which is angle S. And notice angle S is outside the circle, so we would use our formula. So X has to equal 1/2 the big arc, which would be the 179, minus the little arc, which is the 71. Okay, you go ahead and simplify that, and you would end up with 54 as your answer. Okay. Same idea with B, except B asks us to find an arc instead of an angle, but we're going to use the formula. Just have to put pieces in a little bit different spot. Okay, so for this one, you'll notice they give you, should have been a tangent on this side as well. Drawing it kind of like that. This one, they tell you the angle is 68. This is my X that I'm looking for here, and they tell you that this is 224. Okay, so still an exterior angle, so we're still going to use the same idea. Just this time we are going to go ahead and put the angle in for a measurement. So we'll have 68 equals 1/2. Big arc, which is your 224, minus little arc, which is your X. Okay, go ahead again and simplify and solve that, and you'll end up with X equals 88 when you do that. So 2 more here to look at. Okay, for C, okay, C, they give you 2 secants. Okay, so it kind of looks something like this. They tell you that 25 is your angle, X is an arc that you're looking for, and then this one is 110. So very similar to what we did in B. It is exterior, so it's going to end up being 25 equals 1/2 big arc, which is 110, minus the little arc, which is X. Okay, again, making sure it's always big minus little. Okay, go through and solve that one, and you will end up with X equals 60. And then last but not least, now for D, they end up giving you 2 tangents. Now we do need to be careful with these ones. Yes, we're going to solve them the same way, but there's sometimes something extra you have to do, so please pay close attention to this one. Okay, they tell you that LMN is 34. Okay, so they tell you your angle's 34, and they're asking you to find LN, which is your X. Now, it is exterior, so we want to use the same formula. Your first initial thought might be, well, I don't know my big arc. Yes, you do. Okay, because there are 2 tangents, you only have 2 arcs that make up the circle. This would be little arc, this would be big arc. So if little arc is X, that means that we can call big arc 360 minus X, because together they do have to make up the whole circle, which is 360. So anytime you have 2 tangents and you're working with a given angle, more than likely you are going to have to do something like that. So if you're missing it, just be aware of that. Now from here, everything kind of stays the same. Okay, we would end up having 34 equals 1/2 big arc, which is your 360 minus X, minus little arc, which is X. Okay, so you can combine those to make a minus 2X, that's fine. Okay, go ahead and do your normal solving, and you should end up with X equals 146. Okay, so that is working with our interior and exterior angles. Again, make sure you check the daily agenda for the assignment. Don't do the one that's in your packet, because we did make some